Now we are going to start with the compounds of calcium, which is an alkaline earth metal, you know that. So the first basic compound which we are going to study about calcium is the calcium oxide. So what is the chemical name for it? It is a calcium oxide. Otherwise we have a common name too, that is, it is called as lime. What is the common name for it? The common name for calcium oxide is lime. So the first thing is that how we can prepare the lime. So we can prepare the lime by using the limestone. As you know that limestone is CaCO3. So you need to heat it approximately around temperature 1270 Kelvin. It may vary from 1000 to 1270, but not less than that and not more than that. And what is the reason we are going to discuss here? So that means you can heat it in a given temperature range ranging from 1000 to 1270, and it decomposes, and on decomposition it forms lime and carbon dioxide. Lime and carbon dioxide. So one thing you need to do, one thing you need to take care in this reaction, it's that as soon as this carbon dioxide is formed, it has to be removed. The reason being because if it is not removed, it will combine with this calcium oxide and the reaction will occur in a backward manner and it will form calcium carbonate. So the first precaution you need to take is just remove the carbon dioxide as soon as it is formed in order to prevent the reversible reaction. The second important thing for this reaction is that temperature should not allow to rise more than 1270 Kelvin. The temperature should not be allowed to rise beyond 1270 Kelvin. The reason being because if the temperature rises, then what happens? This lime combines with the silica, that is the impurity present in this calcium carbonate. It combines with silica in order to form calcium silicate. So that means we were looking for calcium oxide, but if the temperature will exceed that, so instead of calcium oxide you will get calcium silicate, which we are not looking for actually. So that means we need to take care of the temperature, because like if it is less than 1000 the reaction won't occur, but if it is more than 1270 then it will form calcium silicate. So you need to take care of the temperature, that it should remain between the 1000 to 1270 Kelvin, not less than that and not more than that. And moreover, you need to remove CO2 as soon as it is formed. The reason you are aware now. So if we talk about properties, that how this lime looks like. So it is a white crystalline solid. How it looks like? It is the crystal, it is in a crystal form, and what is the color for the crystal? It is white in color. Second thing is that when exposed to atmosphere, it causes certain reactions. You know that in atmosphere moisture is present and carbon dioxide is present, and along with that we have many other gases also. But the lime actually reacts with moisture very fast and it reacts with carbon dioxide also. So what happens? When it reacts with moisture present in atmosphere, it gives rise to calcium hydroxide. And moreover, we know that it reacts with, as I told you, it reacts with carbon dioxide also. So when it reacts with carbon dioxide, it forms calcium carbonate. So that means when it is exposed to atmosphere, it combines with the moisture and carbon dioxide present in the air, giving rise to calcium hydroxide, which is called as slaked lime, and limestone, which is calcium carbonate. So this is the reaction when it is exposed to the air. Third is that its property, then when it is heated in oxyhydrogen flame, that means when we heat it in oxyhydrogen flame, it emits a brilliant white light. It emits a brilliant white light, and we have a certain name also for that light, that is called as lime light. So this question you may get for 1 mark, that what is lime light. So you should know that whenever lime is burned in oxyhydrogen flame, it emits a white brilliant light, which is called as lime light. That means it is a light of lime, so that is called as lime light. And moreover, how the calcium oxide is formed, it occurs in hard lumps. It occurs in a hard lumps. So we cannot use those hard lumps for any purpose. So what we need to do is that we need to break these hard lumps. And how we do that? We add water to it. So when we add water to the hard lumps, they break, and you can see an identification property is seen because it is an exothermic reaction. A tremendous heat is released, so it produces a hissing sound, and after mixing with water, what does it form? It forms calcium hydroxide, which is slaked lime. So it is also called as slaking of lime. This process is also called as slaking of lime. So if you get a question that what is slaking of lime, so you are going to write that the lime which we get from this reaction occur in a hard lump. So we need to break those hard lumps. So how we do? We add water, and adding water to the hard lumps is something called as slaking of lime, because it results in the calcium hydroxide, which is a slaked lime. Next is that how they behave with acids. I am going to write the reaction here. Suppose I have the lime, I am going to take an acid, let's say hydrochloric acid. So how the reaction occur? We know that it is going to react with this, and moreover we know the valencies also. See, whenever you are doing the reaction, the first step is that just write the valencies. So you need to be familiar with the valencies properly, because the chemistry language is the chemical reactions, and the chemical reactions occur only with the chemical equations, and there you need to make use of the valencies, right? So see, like I have wrote the valencies, so the reaction becomes very easy to solve now. It becomes calcium chloride with water. Right, so this is what is a reaction which occur when it is mixed with acid. Likewise, I can take an example of some other acid. Let's take sulfuric acid. So what happened? Again, I'll write the valencies. It's like this. So obviously calcium is going to react with the sulfate, because positive ion react with the negative one. So we get calcium sulfate with water. So this is actually a kind of neutralization reaction, because we know that calcium oxide is a metal oxide and metal oxides are basic. And here we are mixing with the acids. So acid and base give rise to salt with water, and we know that the name for the reaction is neutralization. So this shows that, so if you get a question like this, that how can you prove the nature of calcium oxide? So you are going to say that we are just mixing with an acid because it forms salt and water. So just it proves that it is a basic in nature, because it is showing a kind of neutralization reaction. So this is how it reacts with acid. Now moving on to this, that how they react with ammonium salts. So let us take an example of ammonium salt. Let's say ammonium chloride. So I am mixing with lime. Again, to do a reaction, I have told you with just you need to write the valencies. So it is 2 positive, 2 negative, ammonium is positive and chloride is negative. So this is going to react with this. So what we'll get? We'll get calcium chloride. Ammonium ion is always liberated as ammonia, and what we are going to get is water. So this is how it is going to react with ammonium salts. Like I have done it for ammonium chloride, you can do it for ammonium sulfate, ammonium phosphate, whatever ammonium salt you can take actually. Next, reaction with coke. You have lime. I am mixing coke. You know that coke is a powder form of carbon only. So it contains only carbon. So what do you get here? You get calcium carbide plus carbon monoxide. This is actually a reaction which is involved in the preparation of alkynes, which we did in organic chemistry, where we were preparing the alkynes. So there what we need is, we need a calcium carbide. So calcium carbide is prepared by this method by reacting the coke with the lime. So when coke reacts with lime, it forms calcium carbide plus carbon monoxide. So I think you know much about lime now. So you know that where this lime is being used. It is used as a flux in metallurgy. It is used in making cement, glass and many other materials. And moreover, you can see that it gives rise to an organic, it is obviously an organic compound, it is obviously a main compound used in a lab, that is the lime. And moreover, I told you that it is a lime light also, and you can see that it can remove the moisture also. So it can actually use in drying up the gases, or wherever we need to remove the moisture, it can be used because it acts as a drying agent. So I think you got it, that where it is being used, flux in metallurgy, drying agent, it is used for drying anything where you need to remove the moisture. It is used in the preparation of limestone, and moreover, as I told you, it is used in the manufacturing of cement, glass and many other materials. And moreover, it is a compound which is used in generally used in a lab in preparing many other compounds also. So this is all about the lime, that is the calcium oxide, CaO.